Hello, students. For today, we're doing something a bit different. Today, we're going to work through a single problem together. We're doing this so I can teach you about an important concept in introductory chemistry called dimensional analysis or unit conversion. With dimensional analysis, you cancel out the unneeded units and end with desired units. Confused? Well, that's okay. We'll work through it slowly. If you're ready, let's start class. All right, students, let's get into it. What is the thickness of paint on the front of a refrigerator in femtometers, that's the FM, that has a length of 6.990 times 10 to the fourth decimeters? Now, that's a stupid number, okay? Don't get mad at me. I just made this up some time ago, okay? And it's good for conversions. Now, a decimeter, a DM, is as big as 60 to 70 houses laid, average size, laid side by side. So you know that's a big number. Okay, let's keep going. And a height of 9.98 times 10 to the fifth hectometers. Now that's like going around the equator of the Earth 2.5 times. Isn't that crazy? Okay, now here's what's given. The density of the paint is 8.99 grams per milliliter and requires 53.8 pounds of paint. And I gave you a little equation at the end. 454 grams is equal to 1 pound. All right, let's solve this. Okay, now I've done a diagram and you know Professor Wall cannot draw. So what you'll see on here is the refrigerator, and all I want is to find the thickness of that paint on the front panel of this refrigerator. So I've tried to lay it out for you. Always write what is given, okay, to keep yourself clear. It makes it so much easier for you as you're solving a problem. All right, now the last thing I want to say is make sure don't leave your density in a fraction. Make sure to make it into an equation. So if the density is 8.99 grams per milliliter, make it into an equation that says 8.99 grams is equal to 1 milliliter. Okay, I've written down things that we have to do. This is multi-step. And so you need to analyze the question, say, oh, how am I going to solve this problem? First thing you need to do is determine the formula or formulas that you're going to need, okay? Think of the front panel like a rectangular prism. So I've written that out. The volume of a rectangular prism is the length times the width times the height. So we're looking for the width, the thickness of that paint. You must find the width, okay? The second thing is that you need to rearrange that equation to solve for the width. And I've written it all out for you. So width is going to be the volume over the length times the height. I always tell my students, circle what you're looking for. And as you know, whatever you do to the left side of the equation, you've got to do to the right side of the equation. Number 3, you're going to analyze the formula and see what you need to solve for. In this scenario, we must solve for the volume first. And then after that, we can solve for the thickness, because that's the only thing we don't have from our little equation. So remember that this density is a conversion unit. If mass to volume, volume to mass, use the density. Okay, now we're going to look at this whole thing together, the roadmap. I like to call it the path, because the path will set you free. First thing I want you to do is change all the units into femtometers. That's what we're going to look for, and that's what we want to write out. So you're going to change your length to femtometers, change your height to femtometers, solve for volume in cubic femtometers. Cubic length is volume. And then I want you to place it into the rearranged equation and solve for the width, which is the thickness, in femtometers. All right now, so I'm doing all of that for you here. Remember, boom, you got to cancel out your units. So you'll see that if you start off with the length being 6.990 times 10 to the fourth decimeters, you've got to put the decimeters in the denominator from our definition. So we found the length, which ends up being 6.990 times 10 to the 18th femtometers. We did the same thing with the height. So then don't forget, boom, cancel out the hectometers, and we end with 998 times 10 to the 22nd femtometers. And look at that volume. It is a long equation. It's a path, multi-step path. Every arrow is a fraction from a definition. But remember, take your definition, always put what you're trying to get rid of in the bottom so that you can, or the denominator, so that you can cancel out those units. Okay, so we end up with our volume being 2.717 times 10 to the 42nd cubic femtometers. Now, do you see how I kept that last 7? We are not done with the volume, so always keep 1 or 2 digits beyond what you need. We only needed 3 significant figures, and you always keep 1 extra digit between operations. Why? Otherwise, you will lose your precision. All right, let's now solve this. So now let's solve for the width, which is the thickness of the paint. We know how to rearrange our equation. Thickness is going to be the volume divided by the length, further divided by the height. And so we plug in our values, and look at this silly little problem. Now, in your calculator, you would input the 2.717 times 10 to the 42nd cubic femtometers divided by 6.990 times 10 to the 18th femtometers, further divided by 9.98 times 10 to the 22nd femtometers. And thus, our resulting answer is 3.89 femtometers. That's the thickness of the paint. Thanks for attending class. We hope this video helped you understand dimensional analysis. If you are confused about the units I used, don't worry. In the near future, we will release another video explaining them. So make sure you like and subscribe to be notified when we release it. Once again, thanks for watching. We are a friend in chem, and our mission is to help students learn introductory chemistry. Our email is in the description, so if there's any way we can make it easier for you to learn, please contact us. Until next time, take care.